Welcome to homework.
Welcome. Uh, we are discussing a problem talking about average life expectancy, and essentially, we are trying to determine the probability of the life expectancy from a certain sample being less than 70 years. So, first off, let's list a few of the things that we know. We know that from the study of life expectancy from 500 people in the given geographic region, our average life expectancy, mu, is equal to 72.0 years. Additionally, we know that for that population of 500 people, our standard deviation is equal to 5.3 years. Moreover, we know that we are trying to determine that the probability of the average life expectancy being less than 70. So we know that we are trying to compare our mu value with our x bar value, and x bar here will be equal to 70 years. Our unknowns that we are currently trying to determine, or that we will determine, are the standard deviation for the population of 50 people. So this is an unknown. Additionally, our z-score that we will be looking at is also unknown. So we're going to put a quick question mark there. Now, we are dealing with the central limit theorem. We know that our sample size n is equal to 50. That is the question. We are looking at from a sample size of 50 people, what is the probability that the average life expectancy will be less than 70 years? So we are concerned with that sample size of 50, and by the central limit theorem, or the CLT, we know that if our sample size n is greater than or equal to 30, our distribution is approximately normal. So this is a key component to helping solve this problem, because given the fact that our sample size is equal to 50, we know that by the central limit theorem, or the CLT, because our sample size is greater than or equal to 30, our distribution is approximately normal. So we know that our distribution is approximately normal, and thus we can check that off. Now, I always find it helpful to look at a diagram to help me figure out what we're supposed to be doing. So drawing a roughly normal curve, I know that's a little rough, but here, let me erase and just sort of smoothen this out a little bit. Oh, here we go. Smoothen this out a little bit. We know that our mean for the population, for the distribution, is 72. And we are trying to look at the probability of the average life expectancy being less than 70. So we are essentially looking at this area right here. I'll actually go ahead and shade that in with red, this area in red, so we can see what our area is. Now, doing our calculations in blue now, we are going to figure out our z-score. So we know that our z-score is equal to our x bar value for the sample, subtracting our average life expectancy for the entire population, which is our mu value, divided by the standard deviation for the entire population, which is also then divided by the square root of our population size. Now here in red, I will just let you know this value right here that I've bracketed out, this is equal to the standard deviation of our sample. That's what I was talking about right there in the box. That is an unknown, so although we won't be directly determining this value, it is important to recognize that this is the standard deviation of the sample. So in a different problem, a problem might give you the standard deviation of the population as a whole, or it might give you the standard deviation of the sample. Recognize this fact and know that you may or may not need to compute this calculation so you can get the actual z-score. Plugging in our numbers here, we have 70 minus 72 divided by our standard deviation of the entire population, which is 5.3, divided by our sample size, which is 50. Once again, reminding you that by the central limit theorem, because our sample size is greater than or equal to 30, our distribution is approximately normal. Using a calculator, you can find this value to be negative, I'm going to give an approximate value. We're going to approximate it to a few decimals. So approximately this value is negative 2.668. I always like going to 3 decimal values just to give myself an accurate value. One can round to 2 decimals, but I would always recommend having at least 2 decimal values so you have a more accurate calculation when you're determining your end result. My teachers have always taught me to round at the end so you can have the most accurate result once you get to the end of the problem, and to continue using as many values as you think necessary throughout the problem. So now we know our z-score, and essentially we are trying to figure out the value of this state, and I'll go ahead and I'll put that in green because now we're getting to almost the end of our problem. So we are trying to figure out the value of this statement where we're trying to figure out the probability P of our z-score being less than negative 2.668. Now, I'll remind you that in your textbook, you may often see the following statement, and I'll write it here in red. You might see the statement where it's you have the probability of your x bar being less than 70, because we are trying to figure out the probability of the average life expectancy for the sample, which is x bar, being less than 70 years. These two statements here are equivalent. So it does not matter which one you use when you're writing it down. Just know that you can write down one or the other or both to show all of your work. Continuing on with our calculation, you can use any regular graphing calculator or scientific calculator, statistic calculator, whether that be online or if you have a TI-84, some similar calculator. You can use any one which you are familiar with, and you can find that our associated probability value is 0.00379, and this is also equal to 0.379%. We are now finished with our calculations, and to sum up and answer in words, we know to answer this question that if a sample of 50 people from this geographic region is selected, the probability that the average life expectancy is less than 70 years is about 0.00379 or 0.379%. I hope that helps, and continue on with your amazing work. Good luck.